Right, we are here and we need to solve for this equation for x. And we note that to solve for x, we need to consider a couple of things and to write down the solution to the problem. So to solve this question for x, or this inequality for x, we have that the modulus of x minus 1 minus 1 squared is greater or equal to 1. We square this, getting x minus 1 squared minus 2 into x minus 1 plus 1 is greater or equal to 1. And this is x minus 1 squared minus 2 times the modulus of x minus 1, like so. The 1 minus 1 gives us 0, and this is greater or equal to 0. Right, and we have got this, and we proceed from here. We've seen that we have x minus 1 squared minus 2 times the modulus of x minus 1, and this result is greater or equal to 0. Okay, just to note that is greater or equal to 0. And then what do we do next? We factor out x minus 1 modulus. And if we do factor out x minus 1 modulus, what do we achieve? Right, would have the modulus of x minus 1 minus 2, like so. Okay. Minus 2, and then you put the close bracket x greater or equal to 0, like this. Okay. What is this? Well, because the product of these two now is greater or equal to 0, it means a couple of things, but what it means is that the modulus of x minus 1, we already know that this modulus is greater or equal to 0. So what we require is that it is the modulus of x minus 1 is greater or equal to 0, and also the x minus 1 minus 2 is also greater or equal to 0, because this is already greater or equal to 0, and we require that this is greater or equal to 0. So that they're both greater or equal to 0, so that their product is indeed greater or equal to 0. Obviously, another case would be if these are both negative, negative, negative times a negative would actually yield a greater or equal to 0. But the absolute value is certainly, obviously, a non-negative function by definition. So we have that exactly, and we proceed then. So what next do we achieve? Right, what we achieve is the following. Right. So we have that from this, it means that x minus 1 is greater or equal to 0, or minus into x minus 1 is greater or equal to 0. And x minus 1 is greater or equal to 2, which means x is greater or equal to 1, or, okay, this at this point means x minus 1 is less or equal to 0 if you multiply both left and right by the negative, so that we have x is less or equal to 1. Right. What is this now? So this is true, and this means that x minus 1 is greater or equal to 2, is greater or equal to 2, or the minus into x minus 1 is greater or equal to 2, which means x is greater or equal to 3. Or if you multiply both left and right by negative, it means this, which means x is less or equal to negative 1. Okay, so we actually have got this here. Obviously, this is greater or equal to 1, or this. All right, so the question then is, what is the solution to everything here? Right, so we can look at what we get out of all this. Right, so what we get out of all this is we can draw a number line like this. And we're gonna put a -1 here. We're gonna put a 1 here, we're gonna put a 3 here. And then now if you consider x greater or equal to 1, so you're gonna have this. X less or equal to 1, you're gonna have that. And then now we continue and you look at the other parts like x greater or equal to 3. Right, so if x is greater or equal to 3, you have these here. X less or equal to -1, you go that way. Right, after this, we're looking at parts where these are simultaneously satisfied, and the solution to the question is given by what? What is the solution to this question? Right, the solution to this question is that we have, because of this overlap here, so we have that x is less or equal to -1, right? Or, and then here you have that x equals 1, or here the overlap as well, so that x is greater or equal to 3. Okay, so this is the solution to the problem. Write x less or equal to -1, or x equals 1, or x is greater or equal to 3. So that gives us the solution to the problem. And so thanks everybody for joining us and allowing us to solve this question. And we can draw from here. Let's just analyze that. In other words, so I can just elaborate and say the solution set. The solution set. We've already seen that is x less or equal to -1, or x equals 1, or x greater or equal to 3, like this. Now, if this is the case, what do we get here out of this? What do we get? We can draw the number line at the end to display the solution. So we have -1, 1, and 3. Less or equal to -1 here. Greater or equal to 3 here. And at x equal to 1. So this obviously is the solution set, and we've graphed it on the real line. And this concludes the problem. And we're excited because we have solved the problem in detail. So yeah, thanks everybody for joining us, and a very goodbye to you.